Hi, in this video I'm going to talk about how to compute descriptive statistics in R. So as you know, descriptive statistics is used to understand the data better. So I'm going to take a data set and then I'm going to show you how you can use various functions in R to compute descriptive statistics. There are various ways you can use different types of functions. I'm going to talk about that. So I'll take the car sales dataset. You might have seen this dataset in my other videos. So those who haven't seen, let's see what's there in it. So it's got the different types of car, different models, different makes, origin, the price, invoice price, length, cylinder, horsepower, and so on. So these are some of the variables or the columns in this particular data set. Some are, as you can see, the names or models which are non-numeric data, whereas the numeric data as well, such as we have horsepower, cylinder, length of the car, weight of the car, and so on. So invoice. So these are numerical variables, but they're also non-numerical variables. And as you know that we cannot compute descriptive statistics of non-numeric variables. Well, we can like count of something, but then we cannot compute most of the descriptive statistics. Okay, therefore we will focus more on these the non-numeric the numeric variables. All right, so there are various functions available in R which can be used to compute simple descriptive statistics such as mean, mode, standard deviation, minimum, maximum, range, and IQR. These are already given functions. You don't have to install any package for that. So when you install R, by default you get these functions. So all you need to do is simply use these functions to compute mean, mode, standard deviations, and so on. So here is an example. So we're going to compute the mean of this particular variable horsepower, which is a numeric variable. That means it's got numbers in it. Okay, and the data set name is car sales. Okay, and then to refer to the variable, this is how we use in R. Those who are familiar with R, I'm sure you know that this is how we refer to a given variable. We first write the name of the data set with a dollar sign, and then we have the column of the data set, okay, that we want to use. And the function that we are using is mean. So here it is. It's also the variable has got quite a number of NA value. That means the not available values. So in order to avoid that, to remove them before computing, what you do is simply state na.rm equal to true. Which what is going to do is simply remove the NA values before computing the mean. Okay, so let's run this. Okay, and you get 215.88. So that is the mean of this variable horsepower. Okay, you can run as many such statistics as you can in one go. Like I'll run mean and median just in one go, and you get it right. You get mean as 215 and median as 210 and so on. But that's about central tendency, right? Mean, median are the central tendency. That means where the data is centered around. So, okay, so that's basically your central tendency, your mean, median, and mode, things like that. But the data has also other aspects. That means variability. So that's another descriptive statistic that we are interested in. And variability can be loosely defined as how the data is varying with respect to the mean value. Okay. Well, central tendency give where the data is concentrated, but the variability will tell you how the data is varying with respect to the mean. Okay, and how you do that? How you get it? Through your mean, your maximum, your range, and standard deviation. And you also got functions for that. For mean and maximum, you have simply mean and max. As you can see, if you run this, you will directly get mean and max of this particular variable. Range is just the maximum minus the minimum. Okay, so range is just subtracting your minimum from the maximum value. Okay, that means subtracting 73 from 500. That's what you're going to get. So let's run this. I'm sure you'll going to get this one. All right. So it ranges between 73 and 500. Okay, but if you calculate range, that means it's just 500 minus 73, which is 427. All right. Then you have standard deviation. For that, we also have a functions st. You can also compute the variance using a function called var. As you know, standard deviation is just a square root of var variance. Okay. So both standard deviation and variance, they tell you how the data is varying, right? A standard deviation, high standard deviation means data is varying with respect to the maximum and the minimum value a lot, whereas a low standard deviation means that there is hardly any variations. If all the values in a given column or even given variable are exactly the same, the standard deviation and so is the variance is 0. That means there is no variation in the data set. So basically standard deviation and variance tell you the variation in the data set, and that's important, especially in data analysis, because oftentimes we are only interested in variables which has large variations. Otherwise they have hardly any information. If a variable has simply constant values, then there is hardly any information in that variable, and it is not very useful. Therefore, when you do exploratory data analysis before building statistical model, you have to compute the standard deviation and the variance of each one of these variables to see which one of them have hardly any variation. Then you can simply remove them, right? That's useful in feature selection, in also in doing feature engineering in many ways. So that's about doing a bit of data exploration around knowing what's the variability of the data. We'll also would like to know what the quantiles. So quantiles in some way can be said that it's also tell you the variability in the data set. Also important when you want to detect or identify the outliers in a data set. So quartiles or quantile distribution is very important to know. And by the way, quartiles and quantile, by definition, there's slight differences there. Okay. So how do we see the quantiles? Well, you have the quantile function. Okay. And so everywhere we're using NA for Rm equal to true. That means there are null values or NA values. We really want to remove them. Okay, so this is how the output looks like. You have 0th quantile, that means the minimum value. Okay, so it goes to ascending order. Okay, 0 percentile 73, which is the minimum value. 25 percentiles 165, 50th 210, 75 percentile to 55, 100 percentile 500, which is the maximum. That means you can see what the data, how the data is varying with respect to the 0th percentile to the 100th percentile, and in between you get to see the 25th percentile, 50th percentile, and 75th percentile of the variable. Okay, and this helps in terms of identifying the outliers, right? Like in some cases, what you can do is simply remove data before 25th percentile and up to 75th percentile. That means the top quantiles or the top percentiles and the lower percentiles, you simply remove them because they are the extreme values, and then use the rest of the observation. It's not that simple though, because it isn't that extreme observations are not useful, but sometimes you may want to do that. Sometimes maybe they are totally away from your central tendency, and simply doesn't make sense to have them in the model. All right, but obviously it needs a bit more analysis, but this is how we can do it. So that's the point here. Okay, then you can also compute what is known as the interquartile range. And what is interquartile range? So interquartile range, or in short known as IQR. So IQR is your value of 75th quantile minus the 25th quantile. Okay, and that's your IQR. So let's compute IQR. So that's 90. That means between 25th and 75th quartile, the difference is 90. And here you see, right, you can verify that also, right, like the difference between 255 and 165 is just 90. Okay. So what if you want more granular distributions? It's not just 5 quartiles where you want to know like at a decile level. That means at 10th percent, like deciles as in every 10th percentile you have deciles, right? So there are 10 deciles in total. How do you do that? Same syntax, is just that you use a sequence. Okay, so sequence starting from 0 to 1 with a range of 10%. Okay, so that's the extra part that you need to add to the quantile function, and then it's going to give you 10 values instead of just 4 or 5 that we just saw. Here you see from 0th quantile to 100th quantile, and in between you have for 10th, 20th, 30th, and so on up until 100 percentile. So you have a proper dissection of the data set, so it's more granular, you can get to see. So instead of removing outliers before, like less than 20 percentile and 70 percentile, it's you may choose 10 percentile and 90th percentile. Okay, so that's better. So you can also have 20th of them. That means okay, let me use like something like, okay, let's try. Does it work? Yeah, that's what it works. That means, so every 5th percentile we have a data point. Okay, so that's even more granular. All right, and then we'll see what is known as a mean absolute deviation. Sorry, median absolute deviation. You can also compute median absolute deviation. So the MAD function, MAD function, it actually gives you the median absolute deviations. Okay, that means how each observations is deviated from the median. Okay, and let's compute this. All right, so what you do is simply it says the sum of okay, I do not remember the exact formula, so I don't want to give you a wrong formula, but you can always Google how to compute a median absolute deviation. So I mean, the intuition here is that to see a summarized value of how each observations is away from, or how far it is from the median. Okay, and if the MAD value is high, that means there is higher variability. The MAD value is low, there is lower variability. Okay, so that's basically what we understand from that value. All right, but here so far we have seen only functions, like that means functions that are already available in R when you download R. But there are also packages which you can install by yourself, and you can also do a lot more, right? It's not just doing individual descriptive statistic we can do at one go. That means you can get many descriptive statistics in just by running one function. Okay, so one of these function is sapply. Okay, and then what you get is mean, median. Obviously you can get many just by using sapply. You can get mean, median, standard deviation, minimum, maximum, median. Like you don't have to write separate functions, just one function and change this value. Okay, so here it is, here is the syntax. Okay, this is your data set, and this is the mean, and it's going to do for all variables. So what I've seen so far is just we've been able to get the descriptive statistic for only one variable, right? Only horsepower in the dataset car cells. But what if we want descriptive statistic for all variables, variables in the dataset? Okay, so we just simply use the dataset name and which statistic we want. That means, do we want mean, and then it is going to compute mean for each one of these variables in the dataset car cells. So sapply is the function to be used. You can see some warning messages. So these are basically for the non-numeric values, because you cannot compute a mean for non-numeric values, and that's why you see the NA values here for make, model, type, and so on. These are NA values. MSRP invoice also comes out to be NA because there is a dollar sign. That's the reason why it is coming, but you can remove that also and then make it numeric. Otherwise, for city, highway, weight, horsepower, you see the mean values, right? So in just one go, you are able to compute the mean of all the variables. Similarly, you can do that for mode, SD, and var, and so on. Okay, SD as in standard deviation. So let's run for standard deviation. Okay, it's the same function, same syntax, just that we have now changed it to standard deviation instead of mean. And here we have standard deviation for each one of the variables. Okay, surprisingly, it gives standard deviation for the make and model. I don't understand what that means. What it means to get a standard deviation of a non-numeric value, but I don't think you can interpret that. But certainly for this numeric value, you can interpret the standard deviation. All right. Then sometimes you can also right away summarize, the datasets. So instead of simply getting mean, median, and standard deviation separately for each one variables, how about using a function which is going to give summary statistics? That means descriptive statistics, such as mean, mode, median, standard deviation, minimum, maximum for all variables in just one go. Okay, that will be really cool, right? And that's for that we'll be using summary, the function summary. Okay, all right. Here you see, right, for all values you have your summary statistics. And what are the summary statistics we have? We have minimum, first quartile, median, mean, third quartile, maximum, and so on. Okay, in fact you can increase the number of values, but by default you only get minimum, maximum, first quartiles, third quartile, median, and mean. Okay, and then further to that, you can also install more packages. Okay, so psych package is one very useful package for descriptive statistics in R. Another package is the PastX. So these two packages you can install, and you can also get summary statistics or descriptive statistics through them. So I've already installed them. Okay, so I'll call them psych, and then I'll use a function called describe, which is exclusive to this package. Okay, if you don't install this package, you won't you can't use this function. So let me see what it gives me. So it also gives me way more values than what summary statistics had given me, right? So summary statistics had given me only a very few, right? Minimum, maximum, first quartile, second quartiles. But here you get many more. Like you get trim mean, you get MAD, you get range, which were not there, right, in the summary statistic or in the summary function that we just used. We also have a skewness, cortices, standard error of that. So it's much more clear, right? It's much more detailed, so to say. So if you are keen on doing exploratory data analysis, this is an extremely useful package, like the psych package. And one function is able to do almost everything that we have just done so far, right? So that's the beauty of this package. Similarly, we can also use PastX. Okay. So we'll it's also a new package, so I've already installed. If you haven't, simply install using install.library, install.package, sorry, and then call using a library function, and then we use start.desc, and then we also going to get summary statistics. Could not find the function. That's good. It seems that it's not installed yet. No, not yet. So I'll install, and then I'll do by myself, but I'm sure you can also use use this function after installing the package and get to see what it actually gives you. Alright, in the next video I'm going to talk about how you can use graphical way of understanding data. That means exploratory data analysis using data visualization. So that's what I'm going to discuss in the next video. Thank you.